Are you rolling?
Say rolling.
Rolling.
It's rolling.
Rolling. All right, we're rolling again. Here we go.
When
Back
did you
at
say
it. All right, cosine. Adjacent over hypotenuse. Adjacent side to A. Since D is already the hypotenuse, adjacent is F, the one right next to it. So I put F on top, and I put D over the hypotenuse. So it's literally cosine of A, adjacent over hypotenuse, adjacent hypotenuse, F over D. And the last one is tangent of A. And tangent stands for opposite over adjacent. Opposite over adjacent. Let's see if you can do this. Opposite over adjacent. So here's A. What side is opposite of A? E. And which one would be the adjacent? F. E over F. Now, if you change angles, these change. What do I mean by that? Well, let's look at B. Let's do the sine of B. Sine. Opposite, hypotenuse. What's opposite of B? F over D. Opposite, hypotenuse, F over D. That's different than the sine of A, which was E over D. So when you change these two angles, these two sets of ratios, they change. Let's try cosine of B. Cosine of B is adjacent. What's adjacent to B?
Next to
E. Hypotenuse?
D.
E over D. Tangent of B. Opposite, adjacent. Opposite is F over E. If it says find the sine, cosine, and tangent of C, right now you can't do it. There are some rules for pre-calculus that allows you to do sine, cosine, and tangent of 90-degree angles, but that's a long ways into the future. And this was really the set of ratios that he walked around the countryside from place to place and developed these set of ratios. Now, there's a huge significance here. Okay? What was his name?
Soh Cah Toa.
Soh Cah Toa. Watch this. Soh Cah Toa. Sohcahtoa. And you say it like Hooked on Phonics works for me because you want to say it phonetically because you don't want to misspell it. Because if you misspell it, you miss the ratio. And whenever you do this, you write it at the top of your paper. So you're doing a trig worksheet. The first thing you do when you get the worksheet is you say, Soh. Oops. Soh. Say it like a samurai. Soh Cah Toa. And trig really didn't come from Soh Cah Toa. It's been around for a long, long time. It was actually invented by the Greeks. There's evidence that they built pyramids with this stuff. That whole thing, I just made all that up because it's the mnemonic device that you use to actually do all of this stuff. Just about every teacher I've ever encountered uses Soh Cah Toa for their right triangle charade. But there was no guy that traveled. There was no TP builder. Native Americans had no idea about this trig stuff. This is a Greek thing. It's been around forever. What's that?
Yeah.
It's like Roy G. Biv.
You lied to us.
I lied.
It's
I
like telling
did.
kids
That's
It's like telling kids. Don't say that. I can't put that on film.
Childhood rude.
What did you say?
Nothing. Nothing. All right. Soh Cah Toa. Now, here's what it's going to end up looking like. Here's what it's going to end up looking like. Type 1. Soh Cah Toa type 1. Find a side. Type 1. And then we'll do an application type also. Now, look at this picture. Okay. See anything kind of significant that has never happened to you guys before? Missing two sides. You know, we did a bunch of Pythagorean theorem problems where we did 8 squared plus 10 squared equals x squared. And we found the missing side with Pythagorean theorem. Well, this trig stuff is so much more powerful because you don't need two sides. All you need is one side and one angle, and you can find everything. You can literally find everything with this stuff. So in a like mathematical power concept, this is way more powerful because I can have one side and one angle rather than needing to measure two sides. So here's how it works. I'm going to write the sine of 48, the cosine of 48, and the tangent of 48. Here we go. Sine of 48 equals, let's do some, I don't like question marks. Let's go like this. Let's go x and y. I put question marks there to emphasize, hey, there's two unknowns. Do the same thing with variables, x and y. All right, what am I supposed to do whenever I do a trig? Soh Cah Toa. S-O-H-C-A-H-T-O-A. All right, sine of 48. Sine stands for O. What is O?
Opposite.
Opposite. Here's 48. What is opposite of 48? 10. Over. H. What's H stand for?
X.
Hypotenuse, which in this case is x. Sine of 48 equals 10 over x. Let's do the cosine of 48. Cosine of 48. Cosine. Look at the letters. Cosine is Ka. Cosine is Ka. A-H. What does the A stand for? Adjacent. Here's 48. What's adjacent?
Y.
Y. The side that's not the hypotenuse. Y. Y over hypotenuse, which is?
X.
X. Cosine of 48 equals y over x. And we got one more. The tangent of 48. Tangent stands for Toa. Soh Cah Toa. Toa. So O. Here's 48. What's opposite of O? Or what's opposite of 48?
10.
10. Over adjacent. Y. Now, I wrote all the trig ratios out. You won't necessarily need to do that. You'll get to the point, hopefully, where you can, in your mind, visually look at it and say, one of these things is not good. One of these things I actually cannot solve. Looking at black, red, and purple, which one, black, red, or purple, do you not like? Dawson?
Red.
I don't like red either. Why don't you like red?
Because they have two different sides.
Two variables. I got an x and I got a y. This one only has an x. Now I know it got sine, but I'll show you how to do that. This one only has y. Well, this one x and y, I get rid of the one that I can't use. I can't use that one. That one is not usable. But this other one here, I can do some math with it. All right, so this is going to look familiar, something that I do here. First of all, you need to take your calculator out. You need to make sure you get the right answer here. Your calculator has two different modes. One of the modes is degrees. It'll say DEG. The other mode is radians. It'll say RAD. In this class, your calculator needs to be in degrees. Usually that's the default setting, so you don't have to change anything. So what you're going to do is you're going to try to find what the sine of 48. This is a ratio, and it will crank out a decimal. So I'm going to hit the SIN button, which is sine. I'm going to hit 48, and I'm going to close it off. And you had better on your calculator get 0.7431. I usually take it to 4 decimal places. If you don't, your calculator's probably in the wrong mode, and you have to change it to DEG. Anybody in here have the wrong mode? Go in your mode setting, and it will say radians and degrees. And you want it in degrees. Was yours in radians?
Yeah.
A lot of the graphing calculators. Yours was in radians?
Yeah.
All right, yours is in radians. So you're going to hit the mode button. Use that until I figure it out. All right, so we get point what again?
7.431.
0.7431 equals 10 over x. That's what I got. Here's what I do. I make it really easy because I want to make it like the last chapter. I go like this. What do you do with something that looks like that?
Cross
Cross
multiply.
multiply. 10 equals 0.7431x. Divide by 0.7431. Divide by 0.7431. What I will try to do is I'll try to use my answer from the previous one. What was the cosine of 48? Oops, clear this. Sine of 48. I actually leave that decimal up and use it if I can. I have to store it on this one. All right, let's just go to 4 decimal places. Let's take 10 and divide it by 0.7431. And out of that I got 13.46. Did everybody get 13.46 here? And this trick stuff, they are decimal approximations. They're not exact. I'll show you how to write the exact answer later, but that's what I got, 13.46. Red one we can't solve. It's time for us to do the purple one. What are we going to do? What are we going to do?
Press tan.
Tan. Instead of sign this time, we're going to press tan. So let's hit the tan of 48. Close it off. I'm going to hit equals. And I got 1.1106. Yes? 1.1106 equals 10 over y. I'll put that over 1, and again, I can cross multiply to solve it out. 10 equals 1.1106y, divide by 1.1106, divide by 1.1106. I got a y value of 10 divided by 1.1106. I got 9.00. It's 004 on mine. I'm going to go to the 2 decimal places, and I got those 2 answers. Did you guys get those on your calculators? All right, let's see if our answers make sense. For the y, I got 9.00, and for the x, I got 13.46. 13.46. Do those numbers make sense? Is the hypotenuse supposed to be the biggest?
Yeah.
Okay. Here's a really easy question now. It's something that you could do very easily. Does anybody know how I could check this pretty easily? Eastman?
9 squared times 10 squared equals 13.46.
Should you be able to do the Pythagorean theorem pretty easy? And you could do this all on your calculator. You don't have to show any work. Let's do this. 9, and you don't really need to 0.00. 9 squared plus 10 squared. Tell me how much you get.
181.
You get 181. Here's the deal. This, it's a rounded version, but if I square this, it should be really close to 181. So take 13.46, square it, and it's probably not exact because, again, we rounded this.
181.17.
181.17, I'd say that's pretty close. If we didn't round, if we had the stringed out decimals, that'd be perfect. It'd be right on. That's straight. We've got a lot to do with that. Got it.